In this video, we will solve a couple of example problems that use our properties of kites that we learned in the previous video. So for this first problem, they are asking us to calculate the measure of angle 1, the measure of angle 2, and the measure of angle 3. Now, two of these do not require any calculation at all because angle 1 is the angle where the two diagonals are crossing. One of our properties of a kite is that the diagonals are always perpendicular to each other. So we know that those angles are all right angles. So right away, we know that the measure of angle 1 is 90 degrees. Additionally, we know that these two triangles, maybe I label them A and B, we know that triangles A and B are congruent to each other, and they are actually just a reflection. So angle 51, or the angle that is 51 degrees, has been reflected over to angle 2. So I know that angle 2 is also 51 degrees. Additionally, we know that this right here makes a right triangle. We have a right angle here, we have that 51 degree angle here, and then this angle is our unknown value, this triangle. So I could do 180 equals 90 plus 51 plus x. And if we solve this equation, we get that x is 39. So we know that angle 3 is 39 degrees. And you notice that they are asking us for the measurements, so I am including that degree symbol. For our second problem, they actually are giving us the outside of our kite. And we know in a kite, those two legs are congruent, and those two legs are congruent. So we can then set these parts equal to each other. We could do 6x minus 3 equals 21, or 4x plus 1 equals 17. If we solve this out, we could subtract 1 on both sides and get that 4x is 16, and divide by 4, we get x is 4. Or we could do 6x equals 24, divide by 6, and we get x is 4 as well. This variable just as easily could have been a y, and then you would have to do both calculations. In this case, I wanted to show you that we could have picked either pair of sides and it would work. The only thing that you can't do is GL is not congruent to LO, and that's obvious down here where GT and TO have different measurements. For our last problem, we have two angle measures again, and they are in different triangles. Now we could use two different properties. We could do the fact that this long diagonal bisects this vertex angle, so we know that these guys are going to be congruent to each other. We could also know that this is just a reflection, so they are congruent to each other. So we know that this angle is also 5x minus 1. Additionally, just like the problem above it, we know that that's a right angle. So we could say 8x plus 5x minus 1 plus 90 is equal to 180. And then we will combine like terms. 8 plus 5 is 13. 90 minus 1 is 89 equals 180. I'm going to subtract 89 on both sides and get that 13x equals 91. And if I divide both sides by 13, we're going to get 7. So my final answer is that x is 7. And we could easily plug that 7 back in and get that this angle is 34 and that this angle is 56, which also confirms that we did it correctly because we knew that these three should add up to 180. And those are some example calculations with kites.